Many applications of light involve widely diverging or just plain large beams. VCSELs and other laser diodes, LEDs, and fiber lasers are used in many sensitive applications with fast-growing markets. To guarantee the performance of these devices in all these applications, characterization of the beam, including power measurement, pulse shape, as well as beam profile and other parameters, is critical. When it comes to analyzing the beam's spatial profile, we run into some serious challenges because the beams are generally large and widely diverging. The apertures of conventional beam profilers are too small to capture the entire beam. Furthermore, diverging beams cannot be accurately measured with a regular detector because the response of the detector is highly dependent on the angle of incidence. It can drop by as much as 10% for each increase of 15 degrees. And a diverging beam is essentially a cone of light covering a very wide range of angles of incidence. Typical solutions for analyzing such beam profiles usually involve bulky laboratory equipment which is not suitable for use in production lines and in situ tests. The new WBI wide beam imager from Ophir solves the problem. It's a compact calibrated optical system for measuring the size and power distribution of large and divergent beams. Beams are captured on a large 48mm diameter diffusive screen and then re-imaged by a CCTV lens through suitable attenuating filters onto the profiler camera. The camera, together with Ophir's beam gauge software, produces a complete and accurate mapping of the light's intensity distribution. Here you can see how the profile of a beam emitted by an LED changes as the LED is moved closer to the diffuser surface of the WBI system. Let's look at an application involving VCSELs. When a VCSEL, or other laser diode, is driven by a low current, it operates in what's known as LED mode. As the current increases above a characteristic threshold, the VCSEL's emission changes to laser mode. This shift happens very rapidly, and measuring exact electro-optical values during this process is highly important. The light current voltage, or LIV, sweep test is used to characterize a laser diode in operation. Observing beam profile changes during such a test provides critical information. For example, here we can see how what begins as a Gaussian beam in LED mode becomes flat top and finally shifts to a dual mode laser beam as the current changes from 0.74 amps to 0.92 amps. Here we can see the WBI accessory together with a profiler camera and beam gauge software providing real-time beam shape analysis and visualization so that changes in the beam shape as a function of applied current can be easily and accurately mapped. When we enter the source to diffuser distance into the beam gauge software, beam gauge then calculates and displays the beam's divergence angle. If we used a regular sensor, this would only be possible for very small divergence angles because of the angle dependence. The WBI, with its 45mm clear aperture and special diffusive screen, lets us work with beams whose divergence angle is up to plus or minus 70 degrees. The WBI operates over a wide range of wavelengths from the UV 350 nanometers to the near IR 1100 nanometers for powers from hundreds of microwatts up to 1 kilowatt CW. It can be used in a horizontal or vertical orientation, with beams having diameters up to 45 millimeters and divergence angles up to plus minus 70 degrees. That's roughly 10 times the divergence angle that can be captured by a regular profiler camera alone. The WBI can be provided as a complete solution that includes beam gauge professional imaging and analysis software and a suitable high-resolution camera, or it can be ordered as an add-on accessory to expand an existing beam profiler camera's capabilities to measure diverging and large beams accurately. The WBI is robust, highly accurate, and easy to use, making it an ideal solution in a wide range of environments, including production, R&D, QA, and service.